Hello everybody, I will start my today another coding practice. So in this video, I will solve this question, my calendar number 2. So I'm implementing a program to use Azure Calendar. So you were implementing a program to use Azure Calendar, I see. We can add a new event if adding the event will not cause the triple booking. Okay. A triple booking happens when 3 events have some non-empty intersection. The moment is common to all the 3 events. I see. The event can be represented as a pair of integers start time and end time that represent a booking on the half open interval. So it should be half open. The range of real numbers x such that start time larger than or equal to x smaller than end time. I mean larger. Yeah, smaller than end time. Implement the my calendar 2 class. My calendar 2 initializes the calendar object. Boolean book int start time end time returns true if the event can be added to the calendar successfully without causing a triple booking. Otherwise, return false and do not add the event to the calendar. Okay, I see. So in this question, I will be, developing the calendar program. And I will be given the events, list of the events. And for each event, start time is inclusive, but end time is exclusive. And when I'm given the, event, I will basically register it to my calendar program. However, if it's the triple booking, I don't register it, or I should say, I can't register it. And I will continue so forth. And if I could register the booking, it will be true. The result is true. And if I couldn't, it would be false. And I will return the list of the result. Okay, I see. So I'm actually quite pretty sure of the question statement. But if I would confirm something more and clarify more, the first thing is the event which is incoming is not necessarily sorted. And the other thing maybe I should take care is, maybe I should clarify the definition of booking. I mean, double booking, triple booking. So when I'm given the booking event, which begins from 10 and ends at time 20. And also, I will assume that I'm given the event which begins at 20 and ends at 30. Maybe like this. So in this case, so this one is included, but this 20 end time is not included. So this 20 times some 20 has no event yet. But if the event starts from 20, it is included in that event. So now, here in line 6, this is the triple booking. I see. Okay, so it's quite clear to me now. So let me get started with thinking of the algorithm. First, let me give some examples. Yep, I think this is good. Example I can use. So firstly, I'm given 10 to 20. Then I will be given 50 to 60. And then I will be given 10 to say 40. And then I will be given 5 to 15. Like around this. Then 5 to 10. Then 25 to 55. Okay, so it should be like this. I actually am not pretty sure if I can sort each, item booking event or not. Because obviously the booking system should, handle the event, I mean, new booking event as a stream. I don't have a way, the calendar program shouldn't have the way to know the future event. So, sorting the events may work, but I don't know if it is a good idea to do that. Oh no. Oh, sorry. I'm telling something. Yeah, stupid. Because book event, I mean, book method is called with start time and end time. So I have to handle this in this method only. Okay, so when I'm given this, so I see. Okay. I would say if I'm given, I will keep track of the timestamp like this. Obviously, first, I don't have any key, but if I'm given the key, I will remember that this should be +1, and for 20, this should be -1. And if I have that in this, set, and if I'm given, say, I'd like to book from 15 to 25, then what I can do is reverse, take a look at from the, I mean, I'm doing the kind of the linear scan from the beginning, and I find that at 15, at time 15, the booking count is 1. And then in line 20, no, timestamp 20, it will become 0. And until time 25, it should be 0. So in the window of 15 to 25, the maximum number count of existing bookings should be 1. So this means that it's okay. I can put 15 to 25 booking like that. And okay, let me think with this example I've given. The 10 to 20, it should be +1 -1. And from 50 to 60, this should be +1, and then this should be -1. Then 10 to 40, this should be now +1. This becomes +2. And in 40, it should be -1. Then I get 5 to 15, so it should be +1 and -1. Then 5 to 10, so it should be +1, -1. Then 25 to 55, this should be +1, and then so again, if I linear scan these, count in a kind of, um, line sweep way, I would say from time 0 to 5, there's no booking, 0. 5 to 10, it should be 2. 10 to 15, it should be 1. 15 to 20, it should be 0. So if I keep track of these, events count diff per each timestamp, when I'm given the time range, I can quickly find how many, the maximum of existing bookings in that time window. Okay. And so I think the challenge here is that I'd like to keep this as sorted. So, if I don't keep this sorted and put the, use this as just a hash map, when I try to linear scan from the beginning, I have to sort this. If I try to sort this, it takes n log n time depending on the existing, past event booking count. Yeah. And so it should take n log n time. But I think I can use the, in this case, I can use the sorted dict. Yeah, I think I can use the sorted dictionary. So sorted dictionary is the dictionary, hash map. Oh, sorry, not hash map, but it's a mapping whose key is sorted. The order of the key is, sustained. So for this one, I can use, put operation, new key appending to take only log n time. And removing key also takes log n time. And say if I'm asked to find so time 15, what I have to do is access this and begins the scanning. So it would take so this access, if the time say 18 is given, I'd like to take a look at the last timestamp, which is smaller than or equal to 18. It would take all log n time. Then I will scan it. But this scan could take all of n in the case when the given time window is so long and I have to scan all the events I've seen. But anyway, with that, the time complexity would be O of n. Yeah. But it seems like, yeah. No, actually, time complexity, I have to scan all of them. The only benefit is that I don't have to sort it anymore. I'm a bit wondering if I don't have to, if there is a way that I don't have to scan it. So let me think. So yeah, I think I can use a segment tree as another solution. With that, literally, it should take log n time only. I don't have to scan it. I have to do the range, range at query to the segment, which is a newly registered window. And also for the checking the triple booking, I just need to do the range maximum query on the segment tree. So it should be login time for each book method. But for now, let me not use the segment tree and let me just use the sorted dictionary. Yep. Hmm. Oh, a small optimization I can make is instead of calculating the total, booking count every time by linear scanning. So say I have 5 to 10 events already. In that case, event becomes 1 here and becomes 0 here. And let me assume that I get 6 to 12 events. In that case, what I should do is take a look at the last time, which is 5. So it should be now 2. 1 plus 1 is 2. Then for 12, I will take a look at the previous. Oh no. Anyway, I have to do scanning from here. So basically what I mean to say is number one, there are two ways. Number one, I keep track of the diff count, diff for each timestamp, and every time I try to check the existing booking count, I linear scan it to build to know the number of bookings per each timestamp. And the solution number two is when I get the booking event. So the sorted dictionary should keep track of the number of events for each timestamp, and I don't do the linear scanning each time. So every time I do register the new event, I will do the partial linear scanning from the timestamp which is close to the given start time. Obviously, I think option 2 is more intuitive and also a bit more optimized because I don't have to scan all the event timestamps all the time. So I will do with this. Again, in the worst case, time complexity should be O of n, and space complexity should be O of n also, which is used for the sorted dictionary. Quickly saying, sorted dictionary is a kind of tree structure mapping. Okay, so that being said, let me get started. So I don't exactly remember the correct interface, accurate interface of the sorted dictionary. So I will I will make it up. So I define this as a sorted dictionary. Yeah. Okay, sorry, let me outline the implementation. Then so this is what I would do. Okay. So I will start the implementation. So event count is sorted dictionary, and yep. So let me say timestamp to count. Let me call it this. Time to count. Let me call it in this way. Okay. So first thing I would do is say the dictionary has timestamp 1, 3, and timestamp 2, 4, and timestamp 5, 6. And I'm looking for time a bit annoying. Time is say 4. So if I'm looking for time 4, the number of count should be, I can know from the timestamp, which is equal to 4. I mean, I can say I need to take a look at the timestamp, the latest timestamp, which is smaller than or equal to 4 in the sorted dictionary. And then that's the count of the event at time 4. So and I will make up the um wait. So yeah, method. But I assume the sorted dictionary has the method to know the key, which is existing key, which is smaller than or equal to 4. Or I should follow the bisect interface, and I will assume that in this way. This. So I made up the method to know the key which is existing in the SortedDict. And in this way, no, wait a minute. I'd like to know the. Okay, so let me assume this sorted set has the kind of index inside, and I can guess the index from that. So I will get yep. So I will assume this is the index. So with index -1, I can know my key index of my concern. I should say interest. And also I'd like to know if I'd like to, you know the range of t is 4 to say 5. Oh no, I just have to scan it until is t becomes 5. If t becomes 5, I don't have to consider it because it doesn't intersect. Maybe so. Yeah. So with that being said, I will iterate. So I will start from here. So if this index is equal to n, which means that um, all the bookings begins before um, the start time. Okay, it's a case when say the booking since the time to count is say time 3, 5, 10, and I'm asking for time t is 1. So in that case, there is no element. I mean time to count index. If I choose any index which is smaller than start time, so in that case I is n. Yeah. So in that case, so no booking a timestamp. And but yeah, I still have to take a look. Wait, so a bit confused, or actually I'm not confused, but I think this kind of complicated implementation is a good way to go. Maybe I think should think where how I can simplify the sort process, even if I do it this way. So if I try to know T4, I will take a look at Rust T, which is smaller than or equal to 4. And if this doesn't exist, this T4 is N. So everything is before. So actually, this I wasn't correct. and all is greater than that, it should be person. Yeah. Okay, so here I get the index from the bisect, right? So when I do bisect right, it's the first index, which is larger than the start time. Yes. So, and it can be exactly length n if all the element is before the start time. So in this case, I can say the booking is 0. So I would say I can return true. Otherwise, I have to do the linear scan from this index. Actually, index -1. So from here, okay, so let me say so in this way I can get the time. So if the time of the event is smaller than the end time. So I'm thinking of the case start and end is given, and I will think of the event which ends at right here. So this end time is larger than the previous event. Yes, I have to take care. But wait a minute. So yeah. Oh, sorry. I'm thinking of the each point. So yeah, each timestamp. So this timestamp is before end. I have to take care the count of this. But if this is equal to the end, I don't have to take care of it because you know this doesn't overlap actually because end is exclusive. So if this is true, what should I do? So here I guess the timestamp. Then oh, this is the index, and all I want to get is the count of this key. So I will make up the key again. I assume that this is how I can get the key value pair. I mean value of the given key in SortedDict. Then yeah. Oh, I'm actually thinking that I should have used SortedSet, and I define the dictionary as a separate data structure. Maybe it should be a little bit easier to implement, but I do it for now. Let me do it. So I set the default as return true. Then in line 83, if I find the overbooking, you know, case, I break it immediately with after setting the return is false. So here, in this way, I get the return. So in the end, I will return this read. And before that, what I have to do is, you know, register the current, you know, start and end times. Yeah. So for the start time, wait, how much confusing is this? So I'm thinking if I can simplify this. Um, Maybe I should have done the rainy scam because it doesn't change the time complexity actually. But anyway, yeah, let me try with this. Oh, yeah, let me stop implementing this. I don't think this is not readable at all. I think I should switch to another implementation. Yep. Okay, so in this way, the first thing I will do is if I get the start and end time, I will just update the, you know, these two data structures so that diff timestamp to diff is updated. Like this. And from here, also I have to append this start time and end time to the sorted times so that I can recognize this timestamp exists in the timestamp list. So yep. Okay. Then oh but sorry. I have to do it after getting the return variable. And only if it is bookable, I have to do it. So And because I don't reserve this, I just can array return. Otherwise, I can return true. And I will register this booking. And in line 62, so okay, as I said, what I should do is from the each timestamp, I will take a look at the diff. And I will update it. And what I should do is the first thing I have to do is if the TM looking is equal or larger than end time, I can finish this iteration because I'm not interested in it anymore. Yep. Then in line, so in this case, I break. Okay, so let me, okay, so instead of doing this, I will immediately array return in the for loop. So this is the case when overbreaking occurs, right? Okay, aside from that, I don't have to take care of the case. I mean, I've covered all of them. Yep. Yeah, seems good. So let me execute my code. I don't know so this set works or not. Yeah. What? Oh, it's now accepted. Oh, I resubmitted. Okay, wrong answer. So let me take a look. This happens. So basically, it needs either diffs. True is, I mean, I return true in the part where false is expected. So this means that I assume that the booking is possible. In the case booking is impossible. Mm. Right. So I should return false here, but I didn't. That's a problem. I'm a bit wondering if this for loop really print out the t, iterates the t in an ascending order. Yes, it in ascending order. This t is an ascending order, which is good. So if end time t is equal or larger than end time, I break. Hmm. I will increment current booking count with diff. If current booking is now T2 and T is the time I'm working is equal to the stunt time or larger, I have to return false. Seems totally fine. Okay, so what I can do is every time I book the event, I will call this. So first I call 28, 4, and 40, and no event registered yet. And then 24, 140 minus 1, yes, it's okay. Then next query is 43 to 50. Then this is appended. Then 27 to 43 is already seen, and 5 to 21. I mean, sorry, 2743 is now appended here, so which is good. And if when I'm taking a look at 5 to 21, I stop the iteration is only 24. Is it okay? Then 30 to 40, I finished it with 40. Wait, why I'm looking at 40? Because now I'm looking at until end 40. So 40 should be, I mean, 40 should not affect. Sorry, but I'm looking at, yeah, before break. So if I do this is correct. Good. So I said I got false in the true in the 1, 2, 3, 4, fifth element. 1, 2, 3, 4, 5. So 30 to 40 case. In this case, I should return false, which is this case. So let me see. Here, it should be like this. And when I do the iteration, firstly, at time 5, it becomes 1. And 21, it becomes 0. 24, it becomes 1. 27, it becomes 2. So it oh wait, this is not before. I mean, this 27 is before the start. So actually, this shouldn't return. Yeah, false. So T is 27 and count the book. So because wait. Yeah. So this shouldn't return false. Yeah. And time to 40, this doesn't matter how many bookings there are. But oh, I see. So it seems like 27 to 40, it doesn't have any booking. I mean, event of the diff. So it's skipped. That's a problem. So what I should do is so at line 27 time line time 27 it should be 2 and time 40 it should be maybe 1 again. I see. So one thing I can do is I keep track of the prev time, and if start time is between the prev time and current time, I should take a look. Okay, let me do it in this way. So here I should check it. If so I should take a look at current booking count. Like this. Okay, let me execute my code again. Oh. Good. So I will execute my code again. Okay, and now it's accepted. Oh, so it took so much time, but I will wrap up my today's practice. So today's question was my calendar too. In this question, I had to, um, yeah, yeah. I developed the calendar software, and in this software, I can register new event, booking event, and sorry, I can register new event, no bookings, and if the new bookings causes a triple booking, I have to return false. Otherwise, I will return true and also register the new booking into the software program. And yeah, so I thought of the overall end time complexity solution. And for that, I kept track of the diff. I mean, each timestamp to diff, count diff, hashmap. And also, I don't want to take a look at each possible time. So I also, you know, kept the every existing past timestamps into the sorted set. Yep. And with that, every time I new booking is coming, I I linear scan the time to diff and create this mapping of each time to timestamp to the number of count booking count existing. And I confirmed if the I mean and also then I take a look at start time to end time window, and if the booking count in that window is 2, if such time exists, I return false. Otherwise, it's bookable, and I register the new event to our system. Okay, so let me finish my today's practice with this. Thank you so much. Bye.